When you graph rational functions, remember that rational functions never cross vertical asymptote line, but may cross horizontal asymptote line and an oblique asymptote line. Therefore, when there is a horizontal asymptote line, y equals a not equal to 0, or oblique asymptote line, you need to check where the intersection is. For number 2, the function f of x equals this. Basically, it's a linear over linear pattern. So first step, you need to put this together. I'll put over 1. 1 over 2x minus 5 minus 3. I put the over 1. Cross multiply. This is 1. Cross multiply over here. Make sure you count this is a negative 3. So make things much easier. Negative 3 times 2x, that is negative 6x. Negative 3 times negative 5, that is a positive 15. Therefore, combine like terms, you will get negative 6x plus 16 over 2x minus 5. Using a over b plus or minus c over d, denominator multiply, then you cross multiply, get ad plus or minus bc. That will be the numerator, ad plus or minus bc. So we get a common factor to the top, that is 2. Negative 3x plus 8. We don't want to sketch the graph first. We want to figure out the equation of asymptote line using this Darry diagram. We know the vertical asymptote line, that's a simplified function denominator equal to 0. We don't have a common factor to be reduced. Therefore, we just set up 2x minus 5 equals 0. Then x equals 5 over 2. For x-intercept, that's a root, means make a numerator equal to 0. So we will set up negative 3x plus 8 equal to 0. You will get x equals to 8 over 3. So 8 over 3, 0. For y-intercept, I just plug in f of 0 equals 2 times. For negative 3x, that's 0. So basically 8 left. 2x is 0. That's why it's negative 5 left. You will get the negative 16 over 5. Therefore, I can write down 0. Negative 16 over 5 will be y-intercept. Now we can sketch the graph. For linear over linear pattern, this kind of rational function, we have 2 types of graph. Suppose this is a vertical asymptote line and a horizontal asymptote line. The graph either look like this or look like this. We need to get a horizontal asymptote line. We already got a vertical asymptote line. Horizontal asymptote line, if this is the format, y equals negative 3 will be the horizontal asymptote line. Or you can get from this type of rational function. We know horizontal asymptote line means limit of leading term. Leading term to the top, that is negative 6x, because you have 2 and a negative 3x. Denominator is 2x. So after you reduce, you can get -3. Y equals -3. If you are given this format, you can get vertical asymptote line and then horizontal asymptote line easily. You make your denominator equal to 0, you will get vertical asymptote line. This number will be horizontal asymptote line. Therefore, we will get y equals -3. This will be the horizontal asymptote line. And vertical asymptote line is 5/2 means 2.5. Get x-intercept, that's 8/3, means 2.6. Let's plot over here. For y-intercept, that's -16/5, means 3.2, -3.2. It's here. Now you can sketch the graph. In your mind, remember, if linear over linear pattern, it will be either this one or this one. Normally, we use x-intercept and y-intercept to decide which corner for that graph. This is the real graph for this rational function. For number 3, identify 7 properties of rational functions. For number 1, f of x equals x minus 1 times x plus 7 over x plus 4. For domain, since we didn't reduce any common factor including x, domain and vertical asymptote line will be the same. Original function and simplified function are the same function now. So domain, we will make a denominator not equal to 0, which means x not equal to -4. Then vertical asymptote line will be x equals -4. For horizontal asymptote line, that will be limit of a leading term. So we circle the leading term for each factor. Then we do multiplication. You will get the x squared. Denominator just x. We do limit of x squared over x. Remember, reduce first. So you get x. When we plug infinity to this x, that will be infinity. Y equals infinity means no horizontal asymptote line. For oblique asymptote line, keywords is 1 more degree. Numerator has 1 more degree than denominator. Yes, it is. See, x squared, this one is x. So we got to use synthetic division or long division. Since our denominator is linear, synthetic division is a better way to do it. For synthetic division, remember, root in the corner, no missing power. Therefore, for the top, you have to do FOIL to get the x squared plus 7x minus x minus 7. Denominator is just x plus 4. You will get the x squared plus 6x minus 7 over x plus 4. Root in the corner means the denominator we set up equal to 0. So x equals -4. I will put the -4 in the corner. No missing power. we check x squared x constant number. So we got the 1, 6, negative 7. When you're looking for oblique asymptote line, we only do the first two. Therefore, we got 1. 1 times negative 4 is negative 4. This is a 2. Then put the x plus 2. That will be the oblique asymptote line. For the root, that's the numerator equal to 0. Therefore, we will set up x minus 1, x plus 7 equal to 0. You will get the 1, 0, and a negative 7, 0. Y-intercept, that's the f of 0. For x, you will put the 0, which means this is a 0, 0, 0. Therefore, you get negative 1 times 7 times 4. You will get negative 7 over 4. That will be 0, negative 7 over 4. For whole, keywords is a common factor. No common factor for this rational function, therefore it's not available. Before we sketch the graph on this graphing paper, we use a sign diagram to predict the graph. We draw a number line first. Label root and also vertical asymptote line on this number line. You will get negative 7, negative 4, and 1. For negative 4, that's a vertical asymptote line. For negative 7 is a big dot. 1 is big dot because the graph will pass through these 2 points. Special number, we will choose 0. 0 negative 7 over 4 means negative. This interval, including 0, will be negative. For this rational function, it's all single factor, so we all change sign. The neighbor interval have a different sign. So we got this is a positive, positive, negative here. And we need to sketch oblique asymptote line. For the oblique asymptote line, you have to choose 2 points. You have to choose the intersection of a vertical asymptote line and oblique asymptote line. Therefore, we have a vertical asymptote line as x equals negative 4. I plug in x equals negative 4. I plug in this y equals x plus 2. So negative 4 plus 2. You will get negative 2. Therefore, we got the 1 point, negative 4, negative 2. The other one must be the oblique asymptote line cross x-axis. Therefore, I will set up x plus 2 equal to 0. X equals negative 2. So, this oblique asymptote line will pass through negative 2, 0. Then I will plot negative 2, 0. It's over here. Negative 4, negative 2. It will be here. Then I will connect these 2 points to get oblique asymptote line. For on the very right side, that's positive. Therefore, you will sketch the graph like this. On the left side, you will get positive here. Negative, you got to draw like this. Now, let's sketch the graph on this graphing paper. We will get asymptote line first. -4 is this. Oblique asymptote line, we need these 2 points, -2, 0, and -4, -2. Then go to intercept. We have 1, 0, that is here, big dot. -7, 0. The intercept will be 0, -7/4. It will be here. Then you connect these 2 points, sketch the graph like this on the right side. On the left side, you will sketch the graph like this. This is the graph for number 1. For number 2, f of x equals 1 minus x over x squared minus 64. First of all, we need to factor the denominator. We got the x plus 8 and x minus 8. Since no common factor to be reduced, therefore, original and simplified function will be the same. Domain, that's denominator not equal to 0. Therefore, x not equal to -8 and 8. So we got the x equals -8 and also x equal to 8. For horizontal asymptote line, you will see limit of leading term. We got leading term that's -x and also x squared. So we got the limit as x approaches infinity of -x over x squared. Reduce, you will get -1 over x. Then you plug infinity to this x. Any number divided by infinity will be 0. Therefore, y equals 0 will be horizontal asymptote line. For oblique asymptote line, keywords 1 more degree definitely is not available. For horizontal and oblique, that's either or neither. For roots, you will make a numerator equal to 0. You will get the 1, 0. For y-intercept, that's f of 0 now, equals. Whenever you see variable, that will be 0. So this is a 0. You will get 1 over -64. So you got -1 over 64. 0, -1 over 64. There is no hole in the graph, not available, because no common factor. First of all, we draw number line to predict the graph. We will put the roots and a vertical asymptote line on this graph. We got -8, 1, and 8. -8 and 8 will be vertical asymptote line. 1 is the root. Special number is 0. We plug in 0 to the function, you got the negative number. So this part is a negative. Since the factor are all single factor, we need to change the sign for each neighbor interval. And we need to draw horizontal asymptote line like this. Negative for this right corner definitely go this way. For positive, you have to pass through this 0, definitely go this way. Negative will be go this way. Then positive means go this way for this right angle corner. Now we sketch on this graph. We have -8 and a +8. You always draw asymptote line first. Then locate all intercepts. We have 1, 0 here. 0, -1/64. It will be here. Yeah, very close to that 0. Now we can sketch the graph. This part. And from here goes up. Going down. And go this way. That's it. This is the real graph for number 2. For number 3, first of all, we need to factor. Top, that's cubic factoring. We got the x minus 2, x squared plus 2x plus 4 over x minus 3, x plus 2. Therefore, for domain will be x not equal to 3 and -2. For your vertical asymptote line, that's x equal to 3 and x equals to -2. There is no horizontal asymptote line. There is an oblique asymptote line because the leading term for numerator is 1 more degree than the denominator. So we will work this out. You can use long division or synthetic division. I will show you both ways. Remember that when you use a long division and a synthetic division, no missing term. So we get x third power plus 0x squared plus 0x minus 8 divided by x squared minus x minus 6. The first term divide. So we get the x. Therefore, we got x third power minus x squared minus 6x. Then subtract. We change into addition. Then we change the sign. Therefore, we get the x squared plus 6x, then minus 8. For x squared divided by x squared, that's 1. So x plus 1. That's it. You don't have to figure out what's the remainder. Y equals x plus 1 will be oblique asymptote line. If you want to use synthetic division to work out the oblique asymptote line, only use the first 2 terms. That is 1, 0. The solution for denominator, we got 3 and also -2. So we use 3. 1, 3. Here's a 3. Then we use -2. 1, -2. Here's 1. Therefore, y equals 1x plus 1 is the oblique asymptote line. For the root, we have 2, 0. We set up this one equal to 0. For x squared plus 2x plus 4, in the real number system, it's not equal to 0. It has complex solutions. For y-intercept, we put 0 for x. We got -8 over -6. That is 4 over 3. Therefore, 0, 4 over 3. Whole is not available because there's no common factor. Now let's sketch the number line. We have 3, -2, that's a vertical asymptote line. Then we have 2, 0, that's a root of this rational function here. The test number we choose 0. So we have 0, 4 over 3, that's a positive here. Then we have negative, positive, because this is all single factor. For the oblique asymptote line, I got to get the intersection cross these two vertical asymptote lines. So when x equals 3, y equals 3 plus 1 equals to 4. So we have 3, 4, supposed to be here. When x equals -2, y equals -2 plus 1, that is -1. So we get -2, -1 is here. This will be the oblique asymptote line. Now we can predict graph. On the right side of this 3, that's positive, means this way. Then this is your roots, so going down because it's negative, then going up like this. Less than -2, that's a negative. That means go this way. This is going down like this. So that's the graph for this rational function. From this graph, you could see the graph intersect this oblique asymptote line. We can figure out where. Therefore, I will set up x third power minus 8 over x squared minus x minus 6 equals to x plus 1. Then both sides we multiply by x squared minus x minus 6. On the left side, we got x third power minus 8. Then we do the FOIL. So we get the x third power minus x squared minus 6x plus x squared minus x minus 6. Then you combine like terms. This 2 is gone. This is gone. So we get -8 equals -7x minus 6. Add 6 both sides, we get -2 equals -7x. So x equals 2 over 7. And for y, we plug in x plus 1. So 2 over 7 plus 1, that is 9 over 7. So intersection of oblique asymptote line and the graph, that is 2 over 7 and 9 over 7. Now let's sketch the graph for x equals 3. That's the vertical asymptote line. And x equals -2. X-intercept, that's 2, 0. Y-intercept, that's 0, 4 over 3. Then you need to graph for oblique asymptote line. Get those 2 points, 3, 4, and a -2, -1. Then I connect points like this. Now we can sketch the graph. This is the real graph for number 3.